Hello, everyone. My name is Nicholas.
And I'm Ryan, and we looked at two variations on the case server problem that we saw from class. So the first is generalized case server. And this is pretty similar to case server. There are still case servers, but each resides in its own world. When a request appears, a shadow of that request appears in each world. And in order to satisfy the request, we just have to move to one of those locations. So interestingly, this problem has a doubly exponential known lower bound. But with some specific constraints, the papers that we read gave competitive algorithms that are both deterministic and randomized.
So the second problem that's related to case server that we have studied is the K-taxi problem. This problem is again very similar. Instead of case servers, we have K-taxis, and requests have a start and an end position. To serve a request, we need to send a taxi, pick up the passenger at the starting position, and then move to the end position. There are two variations for this problem. In the easy variation, we consider every movement that a taxi makes as cost. But for the hard variation, we only consider cost the movement to get to the passenger. And then when we're taking the passenger somewhere, we don't consider that as cost. The papers that we've read present a reduction from the easy version of the problem to the K-server problem, achieving essentially the same competitiveness ratio. Besides that, they also provide some competitive algorithms, randomized algorithms for hierarchically separated trees and matching lower bounds.
So the last thing that we considered is a combination of the previous two settings into the generalized K-taxi setting. And this follows pretty directly from the previous ones. In this setting, we have K-taxis, and each taxi lives in its own world. When a request appears, a person appears in each world with a ride that they want. And in order to serve the request, we just have to give one person a ride, and that serves everybody. So there are a couple of interesting open questions for this problem. One of them would be, is there a reduction to generalized case server, which we know that we have competitive algorithms for? Another interesting question is, could the K-taxi competitive algorithms that we read about be applied to the generalized K-taxi problem? And we worked on these questions a little bit, but didn't get to a definite answer.